Well, hello and welcome to the channel. We are going to be doing a little flight in the Delta Airlines DC-3. This is ship 41. And we're just going to be flying around and trying to test out some things and show you how to get the DC-3 started. So without further ado, let's go ahead and get in the cockpit and get the old girl started up. And as we go along, we'll talk a little bit about the DC-3 itself, as well as the history of Ship 41, which is the only remaining Delta DC-3. So let's get started. Alright, so here we are inside of DC-3, Ship 41. We'll go ahead and the first thing we want to do is set our cowl flaps to full open. And then we'll pump up our hydraulic pressure. So to do that, we turn that valve there, reach our manual hydraulic pump. Give about 6 pumps and then turn that valve back closed. And that should give you right around 400 pounds on your hydraulic system there, which should open your cowl flaps. Pretty much every system, landing gear flaps and things of that nature are hydraulically controlled on the DC-3. So over here we've got this set in our takeoff position. We'll go up here, make sure that our battery cart is selected, and we'll deploy ground power there. Here things starting to come alive. We're currently sitting at Atlanta International Airport, Atlanta being the base of Delta. Thought that was a fitting starting point. So battery's on, we have our beacon already on. Go ahead and make sure this is pushed in. That's our master ignition. That pulled in. Mags are off, boosters are off, generators are off, and our avionics are off. Which is how we want that to start. Make sure our props are set to full fine. Throttle is cracked about a half inch or so. Get our fuel turned on, so we'll select the left main over here, and I'll have to slide over here to get the right main there. The technical start procedure on the DC-3 calls for the mixtures to stay at idle cutoff. However, in this particular version, I find it easier to go to full rich as you're trying to start. So we have the boost pump on for the right engine first. As you can see, we have no fuel pressure because the mixture is set to idle cutoff, but as we come up, there you can see our fuel pressure come up into the green. So, fuel pump, booster pump's on, mixture's rich. We'll go ahead and get our starter energized. Let that wind up. Mesh, prime, should be a few blades, and then kick it over to start on both on the mags, and then keep priming it until it starts. At least you'll stay running here. There she goes. Sometimes it doesn't catch on the first try. Got good old pressure, lights out. Trying to maintain around just under 1,000 RPM as we warm up here. That's good there. Go ahead and take the booster off and turn the generator on. And we'll take the left fuel booster on. Make sure you come up. Good fuel pressure there. And we'll come up here and get our starter energized on the left. You can hear that spooling up there. We'll go ahead and mesh. Hit prime. And mags. Keep priming until she starts. She's catching. Oh, baby. And we got a good start. Good, oil pressure's just starting to come up. And lights out there. Pull the right engine back a little bit. As she warms up, she's going to idle a little higher. But we want to keep it around 1,000 RPM. You can already see on our oil temp gauge there to the right, our right engine is already above the bottom red line. It's already coming up to the green on our right engine oil temp, which is a good sign. We'll go ahead and take the boost pump off for the left engine, and our generators can come on. Now we got the generators working, we can go to ship battery and stow the battery cart, get the ground power off. And we'll take our avionics master on. And our radios are up and functional. Temperatures and pressures looking good, coming up into the green. Now we're just going to do a little short flight. Run around to see what we can accomplish. Maybe practice some touch and goes. Just to get a feel for the DC-3 itself. You may notice here, even the windshield wipers are hydraulically actuated on DC-3. A lot of hydraulics going on there. Alright, we're coming up. Good on our left engine there. Cylinder head temp's starting to come up. We'll go ahead and taxi out to the runway, and then we can do a run up there. Do our taxi checks here. We will take this off. This is securing the aircraft with chocks. Take that off, and she should just start rolling nice and easy. Get it turned around here. A little bit tight quarters in this corner we're in, but DC-3 turns around pretty well for such a big aircraft. You do sit up quite high in a DC-3. It's a little misleading here in the sim, but having sat in a real DC-3 cockpit, you're roughly 15 feet off the ground. It's very high up. So here we are holding short of runway 27 left. Go ahead and do a run up and then get ready for takeoff. So first I'd like to come up to 1500 RPM. We are at now. Cycle the props through. If I remember correctly, these are actuated by oil on the DC-3. So what we're doing there is trying to get the warm oil circulating through that prop hub. So when we need to change RPM, it's done very quickly and not sluggish with cold oil in that prop hub mechanism. So that's the props themselves checked. We'll check the feathering operation, do the left-hand side first. and it's coming down feathering, so we'll go ahead and pull it out. You really don't want to stay feathered for too long on these old radials unless you have to. They don't like that drop in oil pressure that happens, and you don't want a main rod bearing for anything. So check the right here real quick. It's coming down nicely. Pull that back out. Generators are indicating good while we're up there looking at that panel. Right prop's coming out and feathered properly, so that's good to see. Yeah, good oil pressure, good fuel pressure. Oil temps have come up nicely, so our head temps are sitting nice in the green. We'll come up to right around 30 inches of manifold pressure, and then we'll check the magnetos. So there's 30, that's giving us roughly about 2,300 RPM roughly. Check the right. A little bit of a drop there. Coming back up. There's the left. Slight drop there. And then the left one here. A little bit more of a drop, but probably wouldn't fly with that much drop in real life, but it'd be fine. So that's that. We got good hydraulic pressure over here. Everything's in the green. Temperatures and pressures. We'll pull the throttle back to idle. And these old radials, they don't like to change speed quickly, so be mindful of that when you're making your throttle movements. Keep them nice and even and steady. You don't want any power chops, and that goes for really any aircraft engine, but the radials especially, because they have so much rotating mass there. I mean, this particular aircraft, we're talking about engines that have displacement of around 1,830 cubic inches, so quite a lot of rotating mass there to try to speed up and slow down, so you want to be mindful of that. Got plenty of fuel on board, so we got about 90, a little over 90 gallons in each tank. That's plenty of fuel for what we want to do. So we'll go ahead and take our landing lights on. Nav lights are on. Pitot heat can come on. Boosters for right and left. Set our cowl flaps to trail. For takeoff, mixtures are full rich, or auto rich I should say. Full rich is really only used in emergency situations. You may wonder why I didn't check the carb heat there. From what I've read on the DC-3, carb heat is rarely used except for in extreme cold, and our outside air temperature is above freezing. Looks like it's right around 20 degrees Celsius, so that's plenty of temp for what we're trying to do. No need for that carb heat. Alright, well that's the run complete. We'll go ahead and get out onto our runway here and get our takeoff going. Just confirming that's 27 left. Get lined up on the center line here. Get her stopped. Lock the tail wheel. And everything's still looking good, so we'll go ahead and advance the throttles up to 46 inches manifold pressure. It's about 30. Everything's still looking stable. We'll come off the brakes and keep it rolling. Tail coming off there. We're going to keep her on the ground until right around 85 knots. If I could keep her on the runway, that would be a good idea as well. There we go. There's 85, 90. We'll go ahead and rotate. And we do have positive right there, so gear can come up. Being such a big airplane, the DC-3 relies heavily on trim. Elevator trim is your friend in this airplane. I'll go ahead and level off here. Around 1,500 feet AGL. And we'll pull the power back to around 30 inches. And around 1,900 RPM. There we go. And I'm still climbing a little bit there. Trim down a little bit. What's interesting about Ship 41 is she was one of the original DC-3s acquired by Delta in the late 30s. And she's the only one left. The rest of them have unfortunately been scrapped. And it was quite the endeavor to get Ship 41 back into the States. When they found Ship 41, Delta was attempting to start up their museum. They wanted something to commemorate their heritage. So they went searching for any and all aircraft that had done anything with Delta. And they found Ship 41 in Puerto Rico, I believe it was. Running cargo. And she was not in great shape. They ended up replacing several parts on site and got her running again and started the flight back to Georgia. They didn't land at Atlanta International. They landed a little bit south up there to initially. The first stop was Fort Lauderdale. But quite an interesting story about how they got her back. They took off, and almost immediately after takeoff, they lost hydraulic pressure. And they decided, instead of turning back, because the gear was up, the flaps were up, everything was safe, and they could still use the manual pump to get everything down, they decided to continue on, because it was either continue on or turn back around and get stuck in Puerto Rico for another few days for parts to arrive. So they decided to continue on, and somewhere in the middle of their journey to Florida, they lost electric power as well. So they lost all their radios, lost contact with their dispatcher that was keeping track of them, that they were given position reports to, and everybody had thought they went down. Then about 4 hours later, they showed up in Florida, safe and sound, and everybody said, "Where you been? We thought you'd gone down." They were already prepping the Coast Guard to go out and look for them and everything. Now, they eventually put forth significant effort, stripped Delta 41 down to bare aluminum, and rebuilt her to better than new condition, and flew her to a few air shows, and then parked her in the museum in Atlanta. She can still go see today. Now, Delta 41 was a Wright-powered DC-3, and the one we have here in the sim is a Pratt Whitney-powered DC-3. There's a few differences there, being some of the controls are slightly different. The throttle quadrant itself is one of the biggest differences you notice right off the bat. If I remember correctly, the position of the carb heat and the mixture is switched. So the mixture would be up here where the carb heat is, and the carb heat would be back here on the throttle quadrant itself for the right-powered aircraft. Pratt Whitney is a double-row 14-cylinder engine, so 2 rows of 7. And the Wright Cyclone that was on DC-3s is a single-row 7-cylinder. So it's the same displacement, but it's only a single row of roughly the same displacement. I think it's 1820 to 1830, so roughly the same. And the engine is just a single row and a little bit wider circle. And they produce about the same amount of power. The Wright engines are actually the same ones that were on the B-17, the Wright Cyclone 1820s. Very good engine, very solid. In fact, a lot of people prefer the Wright engine powered DC-3s. From what I've read, it's because that they're lighter engines and you can carry just a little bit more cargo. I'll try to get slowed down here just to make a landing for the fun of it. We're at 25 inches. It's a pretty good number. And from what I understand, there's really no speed restriction on the gear on a DC-3 unless it has gear door mods, which we do not. So you can drop the gear at 170 miles an hour with no repercussions. Very stout gear design on the DC-3. Hence why they still use them in Alaska and Canada and other places, because they are built like tanks. Speed bleeding off there at 150. We'll try to keep about 500 foot a minute descent here. Start trimming back. There's 140. Try to make this a pretty landing. Now, in landing the DC-3, you want to come across the fence at around 100 and touch down right at stall speed, roughly, which is right around 70 to 75 miles an hour. And that's what we're going to try to do here today. Hopefully, if I can get this thing straightened out here. We'll power back to 20 inches. Since we're below 140, we can stay square of the power. Go ahead and drop a quarter flap. Coming down past 120. I'm coming a little hot. A little high. A little fast. Go half flaps right there at 112-ish. Got plenty of runway, so we'll just go ahead and stick with it. And 3/4 flap. Pull power out since we're over the threshold. And props pull forward. To get ourselves slowed down. And we'll try to do a tail low wheel landing. That wasn't bad. Keep her on the runway here. She's a big old tail dragger. There we go. There we go. Tail down. And we'll come on the brakes a little bit to get her slowed down. Tail wheel come unlocked. scooch off the runway here to the left. Now, if you notice, I didn't chop the power there to try to lose altitude. It's really something you want to try to avoid in these old radials, especially on a long descent at high speeds. So what will end up happening is something called backloading. Essentially what happens is if you have the manifold pressure below the RPM that you're trying to turn with the props, the prop itself will begin driving the engine. And that is a recipe for master rod failure. The bearings there in the master rod. Because what happens is you're putting force in the opposite direction that the lubrication was designed for, and you lose your oil film between the crank and the master rod bearing. So when you're cruising above 140, you want to try to keep a 5 spread between. So in other words, if your manifold pressure is set to 20, or if your RPM is set to 2000, let's say, you want to keep your RPM or your manifold pressure at 25. So you want to keep that 5-degree spread, so to speak, between your manifold pressure and your RPM. And once you're below 140, you can go square of that. So you notice I went to 20 and 2000 RPM, so that's square, and that's okay.